Hello everyone. There we go. So we're going to continue on what we were doing yesterday. Basically, we're going to continue on with a book that I basically got called Basic Differential Equations. So we were working out some separable differential equations yesterday. So I will be in the process of doing that for you guys today. And happy Tuesday. It is Tuesday, so hopefully you guys are doing well. And if you guys got to do something productive, don't mind me. I will be there being productive with you. So I think it's about time we get to it. So I will turn off my model for now. So I will turn off my model and then we will start the clock, and hopefully you guys will be able to get stuff that you've been working on done. So let's start the clock. Okay, so I'm actually using a different a different browser, I guess Blackboard app or website. So I think the last time, I have to click on my tablet so my pen can be reactive to it. I think we'll do that. So, oh, yeah, that's very thick. I don't think that's too much. Oh, wait. What am I doing? Not f of x. So, problem F. So it is minus. Yeah, we were working on this yesterday. There we go. That didn't look like a E, it looked like a C to me. That is all equal to 0. Okay. Alright, so I guess we add this to the other side here. Oh, this actually makes it a little bit easier. So, oops. Yeah, that's beautiful. And then we integrate these two sides. That looks very nice. And then, yeah, we're gonna just end up like this. That equals actually the same thing on the other side, only with a different variable. Only we have a negative on this side. And we'll add C here. And I don't think we need to do anything else. Yeah, we don't need to do anything else. Let's see here. So now we're on G. So G is dx dt. Okay, so it's not one. And T. Oh. Aha. So, could have been tricky if I didn't know that trick. And we're gonna do. I actually like this browser Blackboard. It feels smoother. Yeah. Hello, Penn Center. And if you guys are into math streams and want to learn some new knowledge, be sure to check out Penn Center stuff. He is doing basically linear algebra and real analysis on his channel. So if you want to learn those skills and enhance your mathematical magic, be sure to give him a follow. But how are you doing, Penn Center? What is the best part of your day so far? Yep, I forgot to click my tablet again. Okay. And we have DFT there. Yes, you are the most... You are practically, Yeah, why not? Like you've welcomed me into the math community. I'll say you're the mathematical Dumbledore. I wonder who would be Grindelwald in this case. Parish keys? Love it. Nice. I'm glad you do. The only thing I'm kind of really iffy about this is that I don't know how to move side to side with this thing. Like, how do you actually drag your stuff here? Maybe like reduce the size a little bit. Math Dumbledore. I actually like probably will go with like young Dumbledore, young Math Dumbledore before he defeats Grindelwald. Right. Yeah, I actually like this. It's a little bit smoother. So let's just make this. Oh, yeah, okay. Because we're not doing Y, we're doing X this time. So dx. Yeah, that works. And yeah, actually, I like the way it writes. Actually, it feels a lot. It doesn't feel scratchy as like Needle. Actually, it looks pretty nice. It's about a rarely crescent shape. Finally savory. Oh, okay. That sounds delicious. I got that from Wiki. Yeah, I wasn't sure exactly what that was. I was like, what is that? So I guess I have to use my mouse to scroll down. I think we can write it on the other side here. I don't think we need to go down for this. So yeah, we're still on the pen. Okay, cool. So typically we're gonna get a negative in front of here, and then we're just gonna get a U. We're not gonna do the T's yet. Okay, I was afraid that you guys wouldn't see that because I was like, oh wait, I went too far. So it's e to the x. We're not gonna put a c there because we're gonna put it on the other side. I think we could just do tabular with this. So 1 negative 0 plus. Then we take the integral of this, the integral of this. Boom, boom. So now, move it on the bottom now, so. Yeah, this actually looks really smooth. I actually like this. I know I've said that multiple times. Mine had gone, So, oh, that sounds delightful. So t to e, and then minus t to e. And then we'll put plus c. Okay, I guess we're gonna scroll down. So if we do this, yeah, because I think the negative will go into, yeah, we'll go into the exponent, right? Yeah, like my brain. Oh, hey, Castle Bravo. Hey, Castle Bravo test. What's the best part of your day so far? Differential equations, yeah. Been a while since I solved them this way. Yeah. Do I need to? I kind of don't want to solve for x, but at the same time, it's like, do I need to? Probably I should. Because if you put the natural log, then it would be negative. Okay, now I'm mixing myself up. So when there's a number in front of it, then basically you treat that as the exponent of the variable, right? I'm just chilling and reading my own stuff, working through my own problems on the other half of the monitor. Oh man, my brain is a tad fried. How about you? I'm doing all right. I'm streaming for you guys right now, and we're doing math, so it's going good. Because if you do the not h. So if you do the natural log, does it become x to the negative 1? I think that's how it goes. Yeah, because if it's like in front, then it goes like back here. But that means we have to take the natural log of all this mess here. And I don't like the way it looks. So then we're left with x. And we'll just leave it the way it is. I'm not going to bother doing the details here. If you guys see that I'm doing problems wrong, like, let me know right away. Yeah, but if your brain is a tad tired, just like rest up. Just rest up and, like, you know, you could chill with us. No need to, like, have the screen mock you with all the hard work you're putting in. Take a break and just chill with us. The chat is open for you to start chatting. I also ordered 2 books on the deliver, and the delivery said 10 work days delivery. They just arrived today, totally not late. Oh, well, at least they came though. That's an important thing. It's like at least they came in. Actually, let's just scroll down so we can actually have some space. So we're gonna get this on this side, and then we're gonna get this, and we get this. Nice. That looks like a pretty nice. So this is gonna be this one. So this one's gonna be. I remember you guys taught me this yesterday. Okay, so then to get y, we have to take the tangent of these goodies. I have to thank you guys, by the way. Because of the stream yesterday, I now remember this much easier. Now I have to remember secant. I have to remember this arcsecant one. So let's go down because it looks like we're running out of space here. So we got the differential equation of t plus 3t. Okay. Now, is this going to be separable, or is this going to be I have to use the integrating factor here. I mean, the way it looks, I feel like I should use the integrating factor, but I can also make it separable. But we don't know what t is though, so I think we have to figure out what t is. I barely remember how to solve differential equations this way. Nowadays, I just do it through transforms. Oh, well, at least you know how to do it through transforms, though. Actually, like online, I've been learning about. I just learned like linear transforms. I didn't do any problems involving them yet, but I did learn like the linear transform of 1 is like 1 over s, and like let's see if I can remember. So the linear transform of 1 is 1 over s. That's a cursive s, by the way. I wrote it very bad. Yeah, the t to the n, s n plus 1, Laplace of, what was the next one? I don't want to do sine and cosine yet, but might as well get them out of the way anyway. So sine of k of t, that would be k s squared plus k squared, and then the Laplace of cosine is s squared plus then we have the hyper ones, so that would be k minus and then cosine no, I am not. I'm just learning math on my own, Castle Bravo. So, like, I just learned these. I feel like I'm missing one. Because there's like 1, 2, 3, 4. I feel like I'm missing one, though. Which one am I not remembering? Oh, I think I'm not remembering E. So I think it's like e to the a t. I think that's s minus a. These are like the basic ones. Let's see. If you're doing it for yourself, just know that all of these tend to be tabulated. So I recognize most of these, but I have a table of transforms I can just look up in a PDE math book. Oh, that's good. As such, some common ones are useful to know, but don't feel the need to memorize them. Oh, okay. I'm just surprised I remember them. But thank you for letting me know. What do you mean by they're tabulated? Actually, I have to practice like linear transforms and the inverse of linear transforms. Alright, so I think we're gonna do the integrating factor. So, oh, that's supposed to be e. So, t, and then et, like that, like so. Et. Oops, no, not x. Not x, it's t. Okay, so that would be the product rule, thus making it et times dt. And then we integrate both sides. We'll move it over here. So then we're left with a constant. Oh, no. That's not what I'm supposed to write. Now I'm thinking of like the scene from what was it? Was it National Geographic? I think it was. I think it's National No, not National Geographic. Dang, I think it's like the History Channel or something. They made like a little drama called Genius that was about Einstein. I think they also made another one, I think it's like a series, like basically Genius is about the geniuses of the past. I think the second one after that one was Picasso. But I didn't watch that one. I only watched the one with Einstein in it. And I remember the scene when he was trying to race for the equation for general relativity, and David Hilbert was like doing the same thing. He was just basically just racing Einstein for the equation. And I always remember when Einstein's on the board giving his lecture, it's like, this equation works for planetary orbits in this one. Yes, here. Flow of the bond to the sun. Yes, here. I always replay that scene in my head, like especially like if I'm writing profusely. Yeah, I mean, I think that looks right. And that's the last one for separable equations. Okay. The only thing I don't like about this is that I have to use my scroll wheel to go down instead of just using my mouse. Oh, wait, hold on. Oh, you can move. But you just can't switch it. It's just hard to switch. So I can erase. Can I? No. No, so this is the right wheel, so if I want to go down, I have to do this. Okay. So it doesn't work like the way my app works, but it's okay. I have this book that my uni allows called Beta Math's Handbook for Science and Engineers. In it, there's a table of Laplace transforms showing the function on the left and its transform on the right. This handbook I'm allowed to bring to the exams with me. if I need to Laplace something, I can just go to the table, transform what I need to read for the table, do what I need to do, and then look up the table again and transform it back. But my mathematics handbook is not the only one, by all means. No, it's okay. Like, I mean, like, at least you're able to use it, which is pretty good. Okay, so number 2. Oh, we have a word problem this time. Okay, a radio... Hopefully you guys can read my handwriting. A radioactive... I would actually have a PDF of this book, but unfortunately I couldn't find one. So I'm just going to have to write word problems by hand. And if it's too long, then I'll probably just write the details. I'll just read it out loud, and I'll just probably write the details that we need. Okay, so a radioactive substance at a rate proportional Can't you use a snipping tool to just copy and paste? Yeah, unfortunately, I don't have a PDF. I'm actually using a physical book. To the amount of the substance present if 64% of the substance remains after 10 years, what is oh no, whoops. I was writing off the wrong thing. What percentage will remain after... Wow, that is so bad. After 15 years. Okay. Oh, hello, Mavort. How are you doing? What's the best part of your day so far? Oh well, I see how that would be tough to do. Right. I'm also a bit rusty with regards to stuff like separation of variables and Laplace transforms. I usually solve ODEs numerically with algorithms such as... Oh, okay. I haven't done numeral methods. Our case just spoils you. Maybe you guys can like tell me about that and like teach me a thing or two about that. So if 64% of the substance remains after 10 years, what's the percentage will remain after 15 years? Okay, so the rate of radioactive decay, so I'm guessing we'll do a dr for radioactive decay. dt is proportional to the amount of the substance. Well, I'll just do curlies because it says proportional. To the amount of the substance present if it's 64% of the remaining substance after 10 years, what is the percentage remaining after 5 years? Okay, so if it's radioactive decay, I'm guessing it's so the original formula for that, I think it's R. I think that's the original formula for radioactive decay. We'll just call it R. I'm so surprised that I remember that from pre-calc. I believe that's the formula because I know that's an exponential function with a negative and time in it. We just don't know the original substance, but it says like 64% of the substance remains after 10 years. So So 64 after 10 years. So let's just change this. So instead of, so let's make it R. Yeah, let's make it that. That makes it look more nice. That is the keynote version. In very short words, given starting point and an ODE can approximate the next point rather well, making the computer compensate with just doing many simple calculations. It can give you a path, the differential equation, without actually ever solving the problem. Ah, I see. Yeah, because I know that there's some differential equations that can't be solved. That is a keynote version. Okay, specific algorithm that procreates the function. Oh, okay. Well, I'm learning a lot from you guys. Thank you for teaching me that, at least. So this is after 10 years. So if we take the derivative, well, yeah, if we take the differential of this, and it's through t, so then we're going to get p negative pr e so it's supposed to be 64%. So 64%. The remaining substance after. So what percentage will remain after 15 years? Did they tell you the amount? Let's see. Radioactive substance decays at a rate proportional to the amount of the substance present. If 64% of the substance remains after 10 years, what is the percentage that remains after 15 years? Okay. So we don't know what the rate it decays. We just know when it actually. So we know how much is remaining. Let's see. Yeah, I'm looking through your what you typed in Castle Bravo. Like I was afraid that I was rereading something you already typed before. Let's see. I can give you a very simple example using the most simple of all algorithms. Newton's method works as follows. You can find the derivative anywhere due to you having the differential equation. You literally procreate your data by some small time step and then recalculate what your new derivative is in that new spot. Then there's a whole textbook worth of different algorithms for different applications. You have RK, you have Leapfrog, and you have so many more. Oh, okay. Interesting. Intriguing. Yeah, because we don't have the primary principle. Well, you're given like 100% of the substance. only 64% remains. So we know that t is 10 years. I'll just put years. And 15 years. And I think we'll just put r of t. Well, r of 10, actually, we should put that there. R of 10 is 0.64. Wow, my 6 is like so squished. I'm like, yeah, I'm not liking the way I'm writing this. There we go. That's what I wanted. So our main priority is just to get this answer. So, well, I don't need to put a question mark there. So I guess we're gonna have to use this result. I have to use this result to find out how we can do this. Nothing better than having a problem that makes you think, right? So I just need certain values here. So after 10 years, so well, technically, actually, what am I doing? That's what it should be. Do they give examples of word problems in here? Because I know there's like some here. Yeah, they have one example here of a word problem. Let's see. Yeah, in their example, they say a certain population has like PT individuals at time t, and the growth rate is proportional to the size, i.e. So when it says proportional, oops. So when they say proportional, they mean something like this. Is separable, and you can write this in the form integrate the we obtain, assume p is greater than 0. Okay, let's try that then. When trying to explain numeral methods, I think it's easier to start the explicit and the implicit Euler method. What textbook are you using for these exercises? I am using Basic Differential Equations by David Bleecker and George Sordas. So, okay, I guess we'll just separate it then. So put A on this side and R on this side. So we don't know what R of T is. Oh, no, we can't do that. What am I thinking? No. So we're gonna have to make it into, I think, an integrating factor problem. Because minus, yeah, I think that's better actually. So the integrating factor, so we have e to the negative t, and we'll just move that in front, and then we're given t. I mean this one. What is this? Oh, this book. Oh, there is a PDF. Oh yeah, there, like, okay, that's the same amount of pages. I'm doing section 1.1, so it should be on page, where is it? Page 17. Will I get page 17 if I type 17 in here? Nope. I have to like search for it. That's probably why I didn't use this. Because they don't have a bookmark section in this PDF. Yeah, I'm doing this question right here. So it's like page 17 of section 1.1. Yep, 17. Okay, so where was I? Oh yeah. But thank you for presenting the PDF version, Vort. Much appreciated. I think this is going to work better. So then we're given RT. Wow. This is what happens when you're left-handed. I write it, and now I'm starting to write very crooked. Oh, it looks like I'm on a roll. So yeah, we integrate both sides. I'm not going to write that. I'm just going to write, then we're going to get a constant here. So then we have to divide both sides, so we'll write it here. So R of t, which is underneath here, but then again it will also carry up because it's also a negative, so we're going to carry this up here, and then we're given this. which is what we started with, yeah. I don't think that's exclusive to left-handed people. I'm right-handed, and I also have a tendency to skew twist to the right. Or is it is that not what you mean? I mean, like, I'm probably saying what you think I was saying, so yeah, but I'm glad you actually pointed that out. Yeah, it's probably not particular to just left-handed people. I just hate it whenever I write down and it goes into a slant like this. Okay, so we got the equation here. I mean, that's what we started with, which I guess I remembered. So yeah. Yeah, because we divided that. Don't mind it. It reminds me of that. Sometimes I need to stretch. Sometimes. Oh, okay. Yeah, that's fair. Oh, it's break time already. Oh, I think I know why it didn't ring. Because, yeah, because my OBS is on, it's on my systems, it's on my systems activator. On my mixer, so I should probably move it. We'll put it by the music section here. I didn't realize it was break time. But that didn't feel like it took a lot out of me, actually. But I'm glad that you guys are here. So Penn Center basically got like an awesome meal, which is great. It rang for you guys? Oh, okay. I guess it just didn't ring for me. Okay, if it rings for you guys, then I don't have to worry about it then. I think I know what may be the issue. Let me check. Maybe it's when I updated it. It didn't. When I updated my computer. Let me see. I probably have to go into the properties here. Luckily, it's break time and I can just mess around with it. The only thing I can't do is stop the timer. I can't stop the timer. I have to refresh it every time. It's not under my control. It's just a video of a timer. Do I have to go in advanced properties? I'm trying to look for the audio properties here. Oh, here we go. Maybe I have to go in here. Yeah, advanced audio properties. Monitor and output. Okay. I don't know if it will work now, but well, at least it rang for you guys. I don't mind that, as long as it rings for you guys. The hard part of the differential equations is over before the break, so you just have the easy part of this problem left. Yeah, I actually have to calculate it. Because basically so it's like 100%, 10 years, it basically, so if we're given 15 years, we basically have to calculate how much will yeah, because we got 64%. But if it's radioactive decay, does the A have to be negative though? I feel like it should be negative. Why is it positive? I mean, I'm so used to seeing like radioactive decay, like I guess like maybe A is supposed to be a fraction or something. Once you do the calculation, odds are it will become negative. Oh, okay. Yeah, because we still don't know what the rate is and what the original amount is, but I'm guessing it's supposed to be like 100% or something. It's funny, it's break time and I'm still thinking about the problem. Just shove in what you know, like T0, T, Y, and the rest is just simultaneous, like the equation you would do in high school. Yeah, it's funny because I never learned this in high school. I learned it in college. And I learned it when I went back to college. Like when I tried to actually go for an engineering degree. But then I ended up basically like, you know what? Like, I'm gonna try to like learn math and physics. But then like, it became too much because I was working at the same time. And I was working a 12-hour shift. And I had to use my vacation time to leave early just to go to class. I practically had no time to myself and I just really, really hated it. So then I ended up dropping out because I was like, nah, I can't do this anymore. But thank you for the suggestion, Castle Bravo. Actually, Castle Bravo, I'm guessing you're a student, or are you already working like in STEM or something? Or are you a graduate student? I forgot. Like, I think it's been a while since I've actually spoken to you. You're a student indeed. Okay. Final year of aerospace engineering. Nice. Are you gonna go to grad school, or are you gonna actually like work? Are you gonna actually try to find full-time work like within your field? Or you haven't thought that far ahead yet, which is okay, which is fine, because you just want to get stuff done. I will probably search for work afterwards. Oh, okay. Yeah, hopefully you get something. Because I know aerospace engineering is like, I mean, like, where would you want to work, actually? That's the question. Would you want to work for, like, SpaceX or something? Or do you want to work with just regular, like, airplanes? But I'm pretty sure, I'm pretty sure while you're at it, you're probably going to do, like, certifications before you graduate, right? So you can actually have the certification that says, oh, I can work on rockets, I can work on airplanes, I can work on whatever thing that flies. Yeah, because I think, like, engineers, they have to do, like, an end of a senior project, right? Before they graduate. That should be fun. Like, for building things, I'm very nervous when it comes to building things. Like, unless it's for fun, like, I can just build with Legos. But if it's something, like, electrical or something that requires a lot of, like, attention to detail, I get very nervous because I hate those situations where it's like you fix something, but then you have to be so precise with it, and you have to get the timing correct, otherwise you screw the whole thing up. That's the one thing I get nervous about. I'm in Sweden, so I have a number of options. My most likely option is something like SAB or ESA. There is a launch site near where I live. Oh, okay. But there's also a high chance I will end up in a telecom company as they manage... Oh, okay. I see. I mean, whatever you're aiming for, like, you know, good luck to you. And, like, if it turns out to be a job that you weren't intending to get, but you work there, like, for a short amount of time, hopefully you'll be able to build up to, like, the career that you're aiming for. For me, like, I think, like, career is just, like, an extension of yourself, but it's not the whole thing that makes you, you know? Like, obviously, like, even though you're working, like, as, like, say, like, an aerospace engineer, right? You still have, like, hobbies, you still have other things that don't involve, like, STEM at all. It could be just, like, things you enjoy. I mean, that's why I like streaming, because, like, I can just do as many of the things that I love to do, but I don't have to be, like, I guess, a specialist at them. Like, I think I like math because it just feels as if, like, there's so many patterns in it, and, like, the idea of being able to use, like, squiggles like I call them squiggles because like I think that's the best way to phrase it. It's like that these little tiny squiggles like on a board or on a computer screen, they basically tell you patterns in the universe that you probably wouldn't have been able to figure out unless you had these like mathematical techniques under your belt. And actually, like last night I was actually talking to one of our members on the Discord server, and he was like teaching me a bit about the heat equation. Like he was teaching me, I think, like a little bit about eigenvalues and like the trick to actually solving the, well, not, I don't know, I think we did solve the heat equation, but I wasn't sure exactly where he was going with it. I think I have the original thing we had on notes on it. Let me just bring it down for you guys so you can see. Yeah, so he was like writing a lot of notes on it. So like he was showing me the heat equation, and like he was showing me like how we would derive it. And I wasn't sure where he was going with it, but I was like, I just followed along and tried to like understand as much as I could. Because like I am like, because of like what he was teaching me here, I kind of got inspired to actually pick up linear algebra again. Of course, like I have to like practice like all the way from the beginning with linear algebra. Because like, you know, like I haven't practiced like matrices in a long time actually. Yeah, actually, like the thing of it is that I actually have a second book with me. It's on linear algebra. I really like this book, and it's very worn, and actually hopefully it doesn't fall apart, but I noticed that one of the pages is actually kind of coming off, and I hope it doesn't fall apart on me. The book is called No Bullshit Guide to Linear Algebra, and I apologize for cursing, but that's the title of the book. I really like it because the author doesn't give no nonsense like explanations of what it is, and like he gives you very good examples, and the best thing is that after each like mini section he gives you questions to do afterwards. I actually did like I think 3 questions this morning not before I came on stream, but like, you know, before I did anything today. I usually try to study in the morning a little bit, but recently I felt as if my studies have been, my morning studies is usually getting a little bit depleted because I don't know, I think my brain is like slowly like not wanting to study in the morning at times. But I try to push myself to at least write notes on stuff, like whether it be differential equations or whether it be like any topic that I have in mind, to keep my brain like basically say, hey, like, you know, like it's morning time, like this is your time to actually like learn something. The heat equation is a classic, though I have not done it in a while. I think I had a problem in the transform course exam, which was this. Oh, okay. Yeah, cause like if you guys want to join our Discord server, let me just type it in for you guys. So if you guys want to like contribute your knowledge, or like, you know, want to teach us some stuff that you're researching or whatever, you can come to our Discord server and just share your ideas there. I set it up because I kind of look at that Discord server as sort of like our own little research institute, where basically we share our ideas, we share our methods and stuff. So I think what my friend was trying to teach me was that you have to implement a Laplacian with an eigenvalue to basically solve the heat equation. And I think he was trying to teach me an easier method, which is like, you know, using the eigenvalue instead of what they traditionally teach you. So I have to I thanked him for that, and I'm like, oh my gosh, like he taught me what an ansatz was, and I was like, oh, okay. And yeah, like I think the rest of the notes weren't saved because like we lost, like, because this is the interactive board, and I think we kind of like cut off connection at times whenever we access this thing. I'm writing notes about eigenvalues right now. It's a topic in our linear algebra course starting tomorrow. Ah, I see. Yeah, the only thing I remember about linear, I mean, the things that I remember about linear algebra were mainly, what is it called? It's not Gaussian elimination, is it? I'm probably thinking the wrong name, but I remember like the elimination method where you basically turn a matrix into an identity matrix. It took me a long time to figure out how to do that properly, or like to think of a method that basically made sense to me, because the way I thought of it was like I would go in a triangle. Like from the top number all the way down to the bottom row, and then I would do a triangle in reverse. So I would think of a right triangle that was laying on the 90-degree angle, and then basically I would go down the hypotenuse, like just basically trying to solve and make those like zeros or ones, and then I would do it in reverse when I went back up. That was the only way I could make sense of that method. Also, you guys use ansatz? Yeah, we use ansatz like mainly in I think like differential equations. Yeah, because like my friend basically, like, he was like, are you familiar with ansatz? And I'm like, oh, that sounds familiar, where's it from? And then he basically said like I think it was from Germany, I think. I don't remember exactly. And like yeah, it's about making a guess. So I never gave it much thought because of it's a word in Swedish which means the exactly that. Oh, okay. Well, Germans have their own equivalent word. Oh, okay. Yeah, because I wasn't sure exactly the origin of it. Okay, so I will be right back, guys. Just give me a minute. Okay, guys, I'm back. Sorry to keep you guys waiting. Ansatz is German, yes. Same for eigen and eigenvalue. Yeah, I think I think I heard of that too. The eigen, I gather, but in my lecture they translate ansatz to ansatz. So I just never gave it much thought. Oh, okay. I mean, you know, like some languages share the same word. So, you know, like if it's part of your native language, then like, you know, sometimes you just don't catch on. It's like, oh, you say the same thing? It's like, yeah, we say the same thing. Swedish is a Germanic language. Oh, okay. Thank you for educating me on that. And also, guys, if you like math or physics or both, you know, or you just want a productive stream to tune into, be sure to drop me a follow, please. It really helps the channel, and it also inspires me to keep doing what I'm doing, basically just like studying math with you guys and also chatting with you guys and learning as much knowledge as you as well as like what you guys also are contributing to the world with your knowledge and your awesomeness. So eigen kind of means self. For example, eigennutz equals self-interest. Oh, okay. Interesting. I never knew that. That's actually an interesting word. Eigennuts. Maybe someone should name their Discord server that, the Eigennuts. It's a funny word, but like self-interest, but that's interesting. That's interesting. I actually like that. Eigen is a Swedish, is it pronounced Egan or with the same meaning? So I gather as much. It is just that they don't translate Eigen to in slides. Oh, okay. And also, oh, it's not your native language? Oh, I apologize for making that assumption. I live here for a while. Oh, okay. So what is your native language, Castle? If you don't mind me asking. Okay, I think it's time to get back into the study. And I realized that on my break I didn't turn on my model, so I apologize for that. But hopefully that didn't bother you guys. Get my pen here. It would be the Polish. Okay. Gotcha. Actually, I remember when I used to work at my old job, one of the maintenance guys was Polish. Actually, like, there were, like, I think 2 Polish guys at my old job. And I heard that Polish is the really hard language to learn. So where were we? Oh yeah, we have to, so time at 10 years. So 10 years is equivalent to, almost, I didn't want to write it that way. I want to write it like this, so it'll be easier to handle. So now we have to figure out for 15 years. Okay. The problem is that okay. So maybe we have to do it like this, and then at A. Well, actually, we should do it like that, and 64, and the time is 15. Well, actually, maybe it should be 0. Yeah, it should be probably 0. That's probably better. But we don't even know what it's at 0, but at the same time, it's like, can we work backwards? Maybe we should work backwards. Oops. It currently has its quirks, but it depends on what other languages you know and speak. It uses the Latin alphabet, so you don't have to learn a whole new alphabet. The word conjugation is a nightmare for people learning it. Oh, okay, I see. Yeah, the only languages I know are English and Japanese. I'm not Japanese, by the way, but I love the language, so I ended up learning it for a long time, and I'm still learning it to this day. Okay, so 10 years. The problem is that we don't have A. We don't have A or C. technically we can just make C like 100. So it's like 1. So we just make it 1. I guess that's what we have to do, I guess. Because it says 64%, so it's like, okay, we'll just make it 1 then. So that way we just solve for A then, I guess. I mean, that works. So take the log of, and then take the log of E. Thus, given 10 A. That way we can know what A is. A is equal to the natural log of 64, 10 years, okay. I have so often tried learning Japanese, then gave up again. I lost count. I mean, the thing of it is that like learning I think the tough part about learning a language is like remaining engaged with it. So the way I continued learning Japanese was I tried to make it fun. So obviously I would watch shows in Japanese. So I watch anime like practically every day. Like the thing of it is that like if I'm given the option to like not watch it with subtitles, I don't watch it with subtitles, even though I probably understand like maybe like a good, I would have to say like 10 to 15%. So like I would say just make it fun. Like for me it's like I even bought a math book in Japanese, and I thought like, oh, it'd be interesting to like learn a language like while learning math at the same time. So, since we have that knowledge, so we'll just do this, and then we'll do this for 15 years. Yeah, and I think that will work. Yeah, because it's just 1, so... so E dash, should I put natural log of 164 divided by 10 So let's see. A radioactive decay is the rate of conversion. Let's see, if 64% of the substance remains after 10 years, what is the percentage remaining after 15 years? Did I do this right? Yeah, because when I did the numbers... Oh, wait, oops. I forgot something. I forgot something in my calculations. Oops. No. That's not what I want to do. Uh, 64. And divide that by 10. And then times that by 15. Okay, there we go. I was like, that answer didn't make any sense. So we're given 51.2, well, yeah, like around, so if we multiply that by 100, that gives us around 51.2%. I think that's it. That sounds like it makes sense. Yeah, because if we assume it's just 1, which is what we started originally, and then basically like work our way backwards. I mean, it seems like that's the solution. Yeah, Yeah, because I think that's... we'll see. Because I don't know if this answer is in the back of the book, but we'll just move on. We'll just move on. But I feel pretty great about that one. And if it's wrong, it's wrong. So, you know, I felt like I was using more parts of my brain than I usually would. Oh yeah, we do have a PDF version of this. So let's see if we can just copy and paste. Let's see if this will work. Oh. That is pretty interesting. It looks really nice. It looks really nice when it does that. But then at the same time, does it copy everything? Because I have highlighted everything here, so let's see. Torricelli's law states that under... Can I make this bigger? Oh, that is really super weird. Yeah, just make this a little bit bigger here. Oh, no, not that big. There we go. There we go. Oh, you guys like typed up something. Let's see here. I don't know enough Japanese, so I can't really compare it to other languages. What makes Polish difficult is there no correct word order, grammatically speaking. You can just take words in your sentence and smash them together in random order. And it is correct. You do change word order for stylistic reasons. What stops it all from being a mess is you conjugate words in ways that give them information about what they are referring to, and tense you use in them. Oh, okay. I'm pretty sure languages always have a certain logic to it, even though it might seem kind of strange to like people that are not knowing the language or not used to that type of structure. So you have to learn a whole set of rules or of how to correctly conjugate words so that your sentences make sense, right? So it's kind of like German then. We also use dedication and conjugation a lot. Kind of in a way, though, Polish is a bit comically excessive in that department. Throw in Polish words to play into Google Images, and you have to see like an old meme of that somehow. Interesting. No, I don't have that tablet. Oh wait, hold on. Because actually, I'm trying to remember what's the brand of my tablet. It's a Gaumon tablet. I'm using a Gaumon tablet. Mavort. Okay, back to the problem. States that under certain ideal circumstances, fluid will leak out of a hole at the base of a container at the rate proportional to the square root of the height of the fluid surface. From the base, suppose that a cylinder, so let's draw this out actually. Let's draw this out actually. So I think we'll just draw a hole here. Let's see. Fluid leaks out of a hole at the base of a container at a rate proportional to the square root of the height of the fluid's surface. From the base, suppose a cylindrical container is initially filled to the depth 1 foot. If it takes 1 minute for 3/4 of the fluid to leak out, how long will it take for all the fluid to leak out? Okay. So let's see what info we got so far. So the fluid will leak at the base of a container at a rate proportional. So let's just put DL for leak time. So it's proportional to the square root of the height of the fluid's surface. Square root of the height. Suppose that the cylindrical container is initially filled to the depth of 1 foot. If it takes 1 minute, so time is 1 minute for 3/4, so oops. So 1 for 3/4 of the fluid to leak out, so 3/4 to leak out. How long will it take for all the fluid to leak out? Okay. So let's drag this down here like that. Yeah, I feel the same way. I'm so used to working with SI units, especially with a scientific problem. What else details that we get? Let's see. They said a foot somewhere. Okay, here we go. From the, let's see, the base of the container is at the rate proportional to the square root of the height of the fluid's surface. From the base, suppose is filled to the depth 1 foot. So suppose that the spherical container is initially filled to the depth of 1 foot. So does that mean the height is 1 foot? Let's see. Takes 1 minute to quarter to. I think so. So if it's the square root of 1, then that means it's just 1. Why is it a measurement? I don't know. It's the old imperial system. Because like an inch is like 2 point. I don't think it's 2.5. I think it's 2.3. 2.3 centimeters. Yeah, American units are terrible. Yeah, I don't like them. But unfortunately, America doesn't want to change the metric system to the metric system. I wish they would, though. I wish they would, because we use it in physics and science. So I'm like, why do we have to use it for like everyday usage? 2.54. Okay, yeah. Centimeters. Okay, so I was off by like a little bit. In this case, could it be that 1 in length, it wouldn't change a thing, but still, as a principle, yeah. No, I get it. I wish they would change it, but unfortunately they won't change it because like so many companies use the imperial system. So many companies that make our products, like, you know, cooking and all that stuff, I think they wouldn't want to like implement like putting metrics on cooking ware and like, you know, products, because like we're so used to it. We're so used to the imperial system here in the US. I don't approve of it, but some people are like, no, I don't want to change it because I already spent my time memorizing what a foot is. It's like 12 inches. So, so suppose that the cylindrical container is initially filled to a depth of 1 foot. If it takes 1 minute for, okay, so I'm guessing the height is 1 foot. Okay, then we're gonna have to do the same thing, I guess, with this problem. So yeah, the one thing that's confusing me is that what is the, like, is the height actually 1 foot, or is it like just that's based on my assumptions? The base of the container at a rate proportional to the square root of the height of the fluid's surface. So suppose that the spherical initially filled to the depth of 1 foot. So filled to the depth, does that mean? So does that mean it has like 1 foot of water in it? Oh, what you typed up, Castle. To my knowledge, behind the scenes, a lot of manufacturing companies already do things in metric and then convert it back. I have been told that most shops already have metric drills, taps, screws, and like on hand. Oh, okay. Yeah, I think it's just stubbornness that we Americans don't change it. I remade the timer you got in the corner from scratch. Damn you for making me practice stuff. What do you mean? What do you mean, sensation? Except for Mars weather satellites, they did calculations in empirical units, so they made a mistake and the satellite crashed. Yeah, you have to with 1 unit of water. What do you mean? Have a tube with 1 unit of water? So I'm guessing that's like how much water we have in the container. I opened up Notepad and made a load of functions and boom, timer. Oh, okay. As in a tube. Oh, okay. No, it's okay. That's okay. It's okay before. Basically, like, I'm just like thinking about the question while I'm talking to you guys, so you guys are not distracting. Like, since I'm not studying for a test or anything, I usually consider this as like we're just all chilling in the same room, and basically we're just like doing our own thing, and like basically like we're just like it's like one of those times where you're just basically multitasking, and like you're just thinking about the problem, but at the same time it's like you're talking to everybody else. It's like, so, and then we just bounce off ideas off each other. And then like maybe like that momentary like moment where it's like we're not thinking about the problem, suddenly we just get an inspiration that maybe we have solved something. So it's mainly just like I mainly stream like not only to study but also just to chill. It's just to chill and just basically like learn. But So I'm guessing, let's just draw it. Maybe drawing it will be better. So we have a container. Like we'll just draw it like this. I know it's a bad drawing, but okay. So it states that under certain ideal circumstances, fluid will leak out of the hole at the base of container that at a rate proportional to the square root of the height of the fluid's surface. From the base, okay. Suppose that a cylindrical container is initially filled to the depth of 1 foot. Okay, so I guess we'll just draw it like this. 1 foot. Okay. Oops. Wow, that doesn't look good. So 1 foot. Okay. If it takes 1 minute for 3/4 of the fluid to leak out, how long does it take for all the fluid to come out? So, alright, so in 1 minute we basically, okay. So I think the height is, so proportional to the square root of the height of the fluid's surface, okay. So, yeah, so the height is 1 foot then. Okay. So technically it's... And then... Hey Fizzbuzz, how's it going? What's the best part of your day so far? What's going on here? Sorry about that. I don't know why it did that. Oh, you guys typed a lot. Let me see here. And the flow rate will be proportional to the square root of the problem is to the square root of t. Find h of t. Academic. でもまだいけないもっと頑張らない頑張ってください頑張ってください sensation. Automod don't want me to talk about partial differential equations. Sorry about that, Fizzbuzz. But what's the best part of your day so far, Fizzbuzz? Yeah, I don't know why it did that. Like, was your message basically my PDE swear? 3 pogs and PDEs, very weird. No problem. Automod is weird, yeah. But what's the best part of your day so far, Fizzbuzz? No oh yeah, already read that. Okay. So hold on. So it takes 1 minute for 3/4 of the fluid to leak out. How long does it take for all the fluid to leak out? Okay. And Mavort, you typed in the problem is the derivative of the height to time, square root of the height to time. The height is a... Yeah, so it takes 60 seconds, yeah. For 1/4. H0 fine. Okay, I guess we'll do that, what you suggested. Don't know, can't say. Work is the best part. Watching the stream is fun. That's the best part. Oh, thanks, Fizzbuzz. Okay, so I guess we'll do what you suggested, Mavort. Because I was trying to make a function of like the leak, like how much is leaking. Because the question asked us is like, how long will it take for all the fluid to leak out? But it also involves like the height too, so. I mean, as a view minus this. Yeah, the integrating factor is not really going to contribute much. Yeah, because like it's only minus 1, so it will be minus t. Oops. Then, oops, not d of t yet. Minus. That just results in this. Right. So might as well erase these. And then we just go back up here. Alright, so it's supposed to be h of t. Try to see. So h of t prime, the square root of h of t. Yeah, and we'll probably make it easier to turn this into seconds. So a minute is 60 seconds. So 60 seconds. So then, yeah, oops, no. Change this to height. So we have to find. So we have to find the original h. Oops. Okay, Castle Bravo, thanks for chilling with us today. Thanks for stopping by, and thanks for all the facts you've educated us with in chat. You take care. I don't know where this... Separation of variables. I don't know if you can do that, like the separation of variables. Let's see. Because it's supposed to be like this, right? But t is contained within h. So then you would have to do this. It just seems kind of strange to me. Unless I'm not doing what you're suggesting. Unless I'm doing this wrong. actually, we don't need to do that. I'm thinking of the wrong thing. So I think we have to figure out what C is. We'll just leave it at 1 minute. Because that's what it says in the problem, so we'll just leave it at 1 minute. We just have to figure out what C is. Because it said it takes 1 minute for 3/4, so we'll leave the time at 1 minute. And then we figure out what C is. So divide that by 2. don't know if I'm doing this right, but we'll just proceed on forward here. So it takes 1 minute, so How long will this be? I feel like it might not be 1 minute. Yeah, I don't think that's right. Oh boy. Yeah, it's not right. Yeah, when you say separation of variables, like, I'm thinking of it as a separable differential equation. And, like, when I see it, like, because I know it's, like, basically, like, I'm wondering, like, how do we do this? Like, as if we separate it, then it would, like, I would imagine it be like this. Yeah, because I basically assumed that I had to do the integrating factor because it just looked really strange to me. Let me see. I don't know if that gave you access. Yeah, so I just posted the link to the board. Probably spend like the last couple minutes just learning. It works? Okay. Yeah, like maybe I'm not understanding what you mean by the separation of variables. Because I'm like, how do I separate t from like h? So I'll let you show me what you mean before. That way I can learn something. Hopefully there are more word problems for differential equations so I can better learn. Okay, there's a couple of them. Yeah, okay, so I can have better practice with it. I'll just put my model up a little bit. Because I realized I didn't put it up when I was on break. Let's see. Like, are you planning to write anything, Mavor, or you just wanted to see the board? Hey, what's up, Famish? What's the best part of your day so far, Famish? And also, guys, if you're tuning in for the first time, if you like math or physics and just like productive streams in general, be sure to drop me a follow. I'd really appreciate it. It seems you can't see what I write. Oh, nice. Happy birthday. I'm just reviewing some more math. Nice. Awesome. Yeah, I don't know how to make it visible for, like... Yeah, I don't... like, this is the first time I'm using this, so I don't know how to, like, make it, like, accessible to 2 people. Let's see, what is this? Click on the burger menu on the top left. Oh. On the top left and click live collab. Nice, congratulations. Alright, let's try that. And I think after before it shows us how to do this, like we'll probably end stream from there. But happy birthday, Famish. Happy birthday. Make those awesome memories. 22 is a big deal. Well, not a big deal, but it's like a milestone. There we go. Now I see your cursor moving about. Do you want me to scroll down to give you more space? Okay. Let's see what we got here. Oh, I see what you're doing. So I'm guessing that is supposed to be a 1 over 4, right? Because I see you put 1 like on the other side for like the integral. So I'm guessing that's supposed to be 1 over 4. No, it's okay. It's okay. Now I see what you mean. I think it's because when you wrote like h of t, I think that's when I was confused, because I was like, it feels like it's a function rather than just h. But when you wrote it with h, it actually makes more sense. Yeah, I see. Oh no, the 4 is like, no, like I was able to see the 4. It's just that like when I saw the 1 over 4, it looked like the 1 was a 7. That's why I asked. Okay, but that makes more sense though. So going with what you set up, actually. Oops, now I'm writing a 7. So h is t under 4. But thank you for the guidance. So we'll just put 1 minute for the time here, because we still have to figure out what C is. And we have 3/4. Oh, okay, so we just get rid of the 4 by multiplying it. And, excuse me. 2c plus c squared. And we're going to get a quadratic. So minus that. So unless we can factor it, let's take a look. So 3 minus 1, that would equal -2. Right, yeah. So 0. Can we factor this? Let's see. Okay, let's see what this ends up. Because we're gonna get, like, I think 2 real numbers. If you do minus okay, so we get a negative number on that side, so I don't think it's that. Oops. So I think more likely it's probably going to be this one. But then again, the water is also depleting. Right over here. Yeah, I'm watching what you're writing before. So 1 over so. See, okay, my model's not blocking it. Okay. Since I'm observing, like, I just wanted to see, like, what we got here. So just drag it over here. Yeah, so basically I left it as a minute, and before it basically turned it to 60 seconds. So we're just observing what, because I think Mavort knows the problem better than I do. So I'm just basically seeing trying to learn what they're doing. So let's see, around half an hour. I'm guessing that's what you wrote there for C. So C is like a half. So basically, let's see here. Wasn't there supposed to be a C like in this part? It's like 2 and 60. Yeah, because like, I'm thinking that there's supposed to be a C there. Is right, yeah. Binomial equation. Oh, okay. Well, that was a really interesting problem. Took many wrong turns with that one, or at least I did. I think before it basically knew how to like solve the problem right away. But that's really good. Like, I'm glad that we were able to like share the screen and like actually like interact with like each other's methods. But thank you for teaching me all that, Mavort. Much appreciated. Okay, so I think that will conclude it for today's stream. We'll be back tomorrow. So thank you all for coming in, and if it's your first time tuning into the Math Spellbook channel, be sure to give me a follow, please, because it really does help me out to basically know that there are a lot of awesome math enthusiasts as well as physics enthusiasts, if you're into physics as well, to the channel. So if you want to join our Discord server, you're more than happy to join our Discord server. I will type that out for you guys. So you can join our Math Spellbook Library Discord server and let us know what you're on, like whether you're researching or studying on your own. Like, what is it that you're doing? Like, just basically pop in and like tell us the latest things that you've discovered. And also, if you missed any part of the VOD, you can also tune into our to the YouTube channel. I always upload my VODs there, so in case you missed anything in the beginning, you can also catch up there. In addition, if you want to watch me play video games and chat with you guys while playing video games, you can also check out my Uncle Talks channel. That's like where we really chill and we just basically do like a lot of video games there. Mainly gacha games, but I mostly play like other games as well. So yeah, I think that will do it for today's stream, guys. I will see you tomorrow, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys tomorrow. So take care, guys. Bye-bye.